record like that. Cool? Okay. Can you, like halfway through, come check and make sure it's still going? Because yesterday it stopped.
Alright, cool.
Alright. You should be in your seat unless you were helping me out. You should be in your seat unless you were helping me out with something. And taking a look. Edgar. Taking a look at your test that you're getting back, and as you're doing that, we're then going to transition into our do first. I'm good, thank you though. Into our do first. So what you can do while you're waiting is look at your notes on page 9 and try to find where the student's error was. This is an error that I've noticed is common that we make, and that we also have trouble on quizzes and tests doing these problems where you have to identify an error. So take a look, see if you can find out where the error is. Anyone else? Did I pass out things to your table and the person's not there? Jason, you got yours? Alright, so give it a second, take a look, then I'm going to talk about a few things. And then also, if you're just hanging out, you can be looking at this do first to try to find the error, which is where we're going to come in just a second. Okay, y'all. So, alrighty. So, a few things about your unit test. In general, whenever I give you a unit test back, I will do like okay. Sorry, I'm okay. Oops, that was close. Hey, Eli. You'll see. Do you need some? Okay, cool. You'll see, like I have here. Everyone, thank you. You'll see a table that has the standards and their title to kind of refresh what each one was about. And then you'll see your grade, and underneath it shows the questions that each one came from. So the questions, for example, for standard 4 were, for standard 3 were 2, 5, 7, and 11 for multiple choice, and then 12A and C and 13A and B from the free response. For the multiple choice, so that you can see which ones you got and which one you missed, I've got the multiple choice answers down below that are correct, and you can flip through your test and kind of mark off the ones you got and the ones you missed as you go through. Okay? In general, what you see, these 3 scores might be different than what you see online. I'll repeat that again. What you see in these 3 boxes might be different than what you see online if one of your grades was a below a 7. Because of Hurricane Harvey, there were some changes in our grading policy to where if people had below a 7, I was allowed to help you out more and bump those failing grades, because I didn't really give you all the opportunities that you would have had to test on that standard and retakes and things like that. Therefore, I wanted to give you your score so that you still see it, even though it might say like a 7 in the actual grade book, calculating your average, and your average might be a little bit higher. So your averages in the grade book, I'm going to repeat that again, are probably higher, but I wanted you to see your actual numbers because in A2, assuming there's not going to be another hurricane, which I don't think we will, I will not be able to help you that much because the grading policy will go back to how it used to be. And therefore, I don't want anyone to get any false sense of like, oh, like, I didn't do any problem sets or participation tracker, and I like ended up still squeaking by with a 72 because that all those got kind of like bumped higher than they would have. And in A2, if you repeat the same things, a 72 is probably going to be like actually a failing grade. Okay? So I just want to like throw that out there in terms of knowing that there's a little bit of extra fluff in your grade because this is a weird grading cycle, but there will not be the fluff next time. Okay? Cool? Okay, if you have questions about specific parts of the test, I would be happy to take a look at those and like answer questions on that more one-on-one. I'll take, if there's any like burning right now, I think the lesson we're going to be okay on pacing. So I'll take like one question, but I can't sit here and go through the whole thing no more. What were you going to ask?
I was going to ask number 3 about how you figured out it was odd, because if it's a square root, wouldn't it be like this? Meaning there's no other point to make it odd?
Okay. So it asked about if g of x is odd. And g of x was negative 2x cubed plus x. So you weren't looking at the square root one, you were looking at g of x.
So number 3?
13?
No, 3.
Oh. That's why. For 3. 3 is a cube root of x. So if I put in a negative x, if I take a cube root, this is not a square root, if I take a cube root, that's going to be the same thing as negative cube root of x, so that's negative g of x, so that is odd. Okay, cool. Okay, so please come chit chat with me if you have some questions. I would be happy to answer. First unit test is always, like in general, I see a lot of growth with people throughout the year. So you will continue to grow, but talk to me if you have any major concerns and I would be happy to help. Okay? Okay, so with that being said, we're going to turn down to our do first. Was anyone else that I didn't already get to not here yesterday? Like Levy got the notes because he wasn't here. Anyone else? Pedro, were you here yesterday? Okay. We are on page 9. What? No, you're good. Thank you. We're on page 9, and you're trying to find where there is an error in this work, because this is a common error I saw when we were like solving things with our inverses and things like that. Okay, so take a look. I'm going to give you about 30 seconds to look at it, and then we'll share out. You need notes too? Okay. Were you here yesterday?
Yeah, but I'm not here.
Okay. Did you get here late yesterday? No. Do you need notes? Thank you. Okay. All right. All right, raise your hand if you can tell me where there is an error in this work right here. What did this person do? Where is the error in their work where they made a common mistake that we make? Catherine?
So it says parentheses 2x plus 2 and then square.
Okay, right here.
Yeah. They missed right there because they didn't distribute like the exponent.
Okay, so they kind of did try to, right? They said 2x squared plus 4. Can we do that when we have an exponent outside of an expression? No. Which I've seen us try a lot. So whenever people move over, they moved over the 2, that was good. Then they go to square both sides. They were good, and I saw a lot of good things there. But then, magically, whenever I have things like this, I have a lot of people that want to write this as like x squared plus 4, and that is incorrect. What would we have to do here to solve that? Cindy? The box, yeah, because this is really 2x plus 2 times 2x plus 2, which to multiply something like that, you can't just multiply the first ones and the last ones, you have to multiply all of them, okay? So what we're going to do right now is we're going to jump straight into like basically our first model of this. There's actually space right below, if you take a look. Right here, it says corrected solution and verified answer. So we're going to pick up right here in this box with now our own work, okay? So from her spot, let's go ahead and do this box. 2x plus 2, 2x plus 2. Go ahead and do that box for me and see what you get while I bring in stamps. There, and I just wrote that. And then, so like I said, this problem is going to change much because this is already accepted. Did you all hear my answers about that? Okay. So I'll change it, but I don't know if it'll change your average, but I'll change it over here. See what you get. Yeah, I heard like the. Oh, I heard trick if you want to see that. I heard more than I usually heard. All right, what we get? What we get? Sheep.
1 squared plus 8x plus 4.
4x squared, a little louder for me.
4x squared plus 8x plus 4.
Cool. Equals, and then on this side we'll have, if you look up above their work, that part was right because they squared it and they got this, okay? So we're picking up on their step 3 or 4 or whatever, but we just fixed the left side of their work. Yep.
So in the end, he said it equal to 0. Or we supposed to equal to 0?
Yeah, so now the goal, again, their process, if you look, the next thing that they did is they moved over things to set this equal to 0. Do y'all think that would be a good strategy moving forward with now? We just have to adjust the numbers, but does that seem like something we should do? Okay, so we're going to now move it over like they did and set it equal to 0, because then once we have a quadratic equal to 0, we can finish solving, okay? So we're going to move things over. If I subtract 100 over, I'll have 4 minus 100 is negative 96.
Yeah.
Cool. If I add the 12x over,
It's going to be 4x squared plus 8x.
what did I, is this a minus 8?
No, it's a plus 8.
Plus 8.
So if I add 12, oh, plus 20, that's what it is, right?
Yeah.
Okay. Sorry, it just all of a sudden looked unfamiliar from what I remember the answer being. Okay, so we're back. Cool. Couple options here. You could box, you could quadratic formula, all the things we practiced at the beginning of Unit 1. If you do your box, you can totally do your box with 4x squared, but if I can avoid having a coefficient up front, then I want to make my numbers way more simple than I have to do my box. So I always check, sometimes you can't avoid it, but I always check if all of these terms are divisible by this number, then I like to factor out that number so that I don't have to deal with it. Are all of these numbers divisible by 4? Yes, therefore, quick trick, you don't have to do this to get the right answer, but you can factor out a 4 and say x squared plus 5x, oops, don't know what I'm doing, minus, I believe it's 24 times 4 gives us 96, equals 0. And now, my box, it's easier for me to do a box with x squared plus 5x minus 24 than all this kind of big number crazy stuff, okay? So now I'm over here, x squared 5x minus 24. Raise your hand if you can tell me what our two numbers are going to be that give us negative 24 and a positive 5 when you add them. Gio?
Negative, no, 8 and negative
8x minus 3x. Cool. So we have x, 8, and minus 3. Cool? So factored, we end up with 4 times x minus 3, x plus 8 equals 0. Okay? And once we have something factored, I like to write it out so one more time I can see everything that's equivalent. That means that this whole thing's equal to 0. The zero product property tells me that either this thing or this thing is 0. What x values would make that equal to 0? Positive 3, negative 8. Cool. Okay, so this is how we could solve a radical equation like this. And what we have to be careful about, there's one more step that is often forgotten when we're solving radical equations, is when we get to the end, we have to now go plug these in and actually make sure that they work in the original equation. Because when you manipulate a radical equation, along the way, often we can actually pick up some solutions that do not work. For example, when I square both sides, remember underneath here, a square root, we cannot have a square root of what? A negative. When I made that square root magically go away, I opened the door again for all positive and negatives, and I thought I could have all real numbers. When I actually, if you look back at the beginning, had a restriction on my numbers, and they might not all work. So I'll repeat one more time. Back at the beginning, there's some numbers underneath here that we can't have. And when I'm looking at this equation, this is what I ended up solving, right? That's what I ended up factoring. Are there any issues with x values in this equation? No. So I got answers here that in my original might not have worked. So those are what we call extraneous solutions. That only happens not when we solve a normal equation, 2x plus 5 equals something, that is a regular equation, you're good. When we solve radical equations and we square both sides and do things like that, then we have to check for extraneous solutions. Yep?
So that's not necessarily what you would plug in up there, but it's a way to solve it? Is that what you're saying?
These are not necessarily both our answers yet.
Okay.
We need to now check them to get to our final answer. So don't box them yet. Okay, so now let's go ahead. We gotta plug them in. So if I plug 3 in, I get 2 times 3 is 6. And on the other side, go ahead and plug 3 in here for me and see what you get. I want to see people trying it. Plug 3 in to the, we plugged it into the left. Plug 3 into the right. See what you get. Raise your hand when you got it. 64. Square root of 64 is, then minus 2 is 6. So both sides are equal to what?
6.
So that works. Okay, let's try the next one. If I have a negative 8, 2 times negative 8 is negative 16. On the other side, go ahead and plug in a negative 8 and see if you get negative 16. Try that out. Can you do it by hand then? So square root, plug in 8 here. Raise your hand if you got it. It's 14. Also been a problem like that. And then we get
Negative 16.
What is 12?
12.
Oh man!
So are they equivalent? This side, this side. No. And so this answer we have to throw out. That is what we call an extraneous solution that appeared to be correct at the beginning, but actually is not a solution of this equation. It's only a solution of this equation that we like manipulated.
So that's like the x's that you don't need.
We don't want that, so we just want x equals 3. Okay?
It's like you're gutting a fish. You don't need the guts and stuff.
Yeah,
Just
throw
the
those out.
x's.
I like the analogy there. Okay, so y'all are gonna try this in a second once we get these things down. So let's define kind of the few things we just talked about. First off, a radical equation. I've been referring to this thing we were talking about as a radical equation. A radical equation is an equation where at least one variable is like stuck inside of a radical, inside of a root, whether it's a cube root or a square root or something like that, and we have to get it out using strategies like the one we just did. So, first, to give you kind of like some goals, right? When you see a problem like this, if you're like, I don't know where to start, here's some points. First, what the person did in the work above that I liked was that the first thing they did is they isolated the radical expression. Take a look one more time up to what they did. What is the first thing that that person did?
Isolated radical expression.
By doing what? Take a look at, yes, by doing what? Look up at their work.
By square rooting it.
That's not the first thing they did.
Plugging it in. No, by equaling it to 0.
Not quite. Yep.
By adding 2.
They added the 2 over first, and so they were able to get that root 100 minus 12x by itself, which is what I mean by isolate. If you put something in isolation, it's like by itself. So the goal was to get that off by itself without the 2, right? Okay. Next, we then, not until you do that, after you do that, is when you can then raise each side of the equation to the power of whatever we call like the index of the radical is like, if it's a cube root, we raise it to this. If it's a square root, we raise it to 2, right? So we raise the power of whatever matches our root. We cannot square both sides or cube both sides until we isolate the radical expression. Okay, and then from there we solve and you do all sorts of things. But remember, at the end it says always remember, and this is the part that I like always forget. Always remember to check for what we call those extraneous solutions that are produced but may not satisfy the original equation. So you've got to go and plug in your solutions and make sure each side are actually equal on your original equation. Not the equation that you created, the original equation. Okay? Okay, so that was our process. We are going to recreate that process. You will notice this first one is what we just did. So we found that one, right? Sorry, repeat. So the first one I want you to jump into right now. Today we're going to do a lot of practice. It's going to be less of me up here and more of you just like really trying it out. I'm going to have you jump straight in to this problem right here. Try it out. If you finish, I'll check it and you can move on. But we're going to wait till everyone has this one and then we'll come back before we look at it the next example. I'm going to set my timer to focus on gotta change this to say Pedro is, yeah, so you're on number 2.
Oh my gosh.
Amelia, can you get started on this one, please? Yes.
Oh, I said press the red button.
Did you finish the first problem? Did you say? Check your answers. When you subtracted the two numbers, you should have had x Okay, so now you're going to do your box, but not the box like as in you're multiplying it together. You have the inside and you want to do the factors on the outside. So you got minus 35 x squared, and you're trying to make a minus 2. So become factors of 35, what times what? And use negative 35 and we'll add 2. Not 6, 7. 7 times 5 is 35. So, which one's negative? Negative 7 and a positive. Yeah, cool. Okay, so first we want to isolate the radical, which looks like you did. You subtracted, or sorry, added the 2 over. Okay. Now, we're going to raise each side of the equation to the power of our radical. If this is a square root, now we're going to square both sides to get the square root 4 over. So we're going to square both sides. When you square it, on this side, you'll have to do your box. You can't just say 4 plus x. So now go ahead and do your box for that part. And see what you get on that side and move everything on over. How you doing now? Better? Yes, now do your box with that. Perfect. Yes.
But the answer?
Okay, yes. So now start moving everything over. Good. Take some people here. So now your two answers are negative 5 and 7, good. And so now you gotta plug those in and see if any are extraneous or if they're both good. So we put them into the, we wanna make sure we're back in this original, because I changed things up, which is why these are the solutions to this equation. You'll get that true. We wanna plug it back in here and make sure it's still a solution to my original. Yes. So you have to, no, you have to plug them into both sides. So plug in negative 5 to both sides and make sure both sides match. Plug in 7 to both sides and make sure both sides match. Cool? Yes, ma'am.
You need to check these things.
Yes. I factored out a 4. Well, you don't need to here. This is not a better. I was just reading that so that I have an x squared and an everything. Let me just check this real quick. Yeah.
No, x squared.
So now you're ready to go straight into your box. If you have a crazy big number right here, like the one that's like 9x squared, you can use it like yeah. So now do your box with trying to factor it.
Okay. So then I put this right here.
Yes. This other one didn't work, right?
Yeah, negative 5 is extra.
Yeah, good. So these are your two factors. X minus 7 times x plus 5.
Yeah.
0, right?
And then you want to see
7, when you start looking at it, we're going to kind of come back and talk because some different things are going to happen.
Right, so just put like
just like, yeah, most probably that.
So it's not like check one out.
she said it's extraneous. So like,
They could both be good or they could both be bad. Come and cheat.
Guys, very great. Make sure we keep it down though.
Minus 7.
We're gonna run out of 7. We're already down 7 in here. Make sure you all get 7. Do you have to look at something? You would have to cancel.
Alright, that was my timer. She had a quick question, so I'm going to run over here. So I'll give you a few more seconds. Then we're going to come back together. So where's your final answer? Good, yes. I found it. There's a line. I needed bigger boxes. Should have provided bigger boxes. Alright. Eyes back up here. We're working on our transition, so if you could quickly close off your conversation, even if you're talking about math, and we love math. If you could pause Carlos's table, you can.
Math is so great.
I'll resume that. I love that you're talking about math, but if you could bring it back for 1 second, and then we you can go back to that conversation, or I'll come jump in if you need help. So for this one, if you haven't finished yet, I'll give you a second to move on and try it out finishing. But I got 7 and -5, but then when I plugged it into both sides of the equation, I got 7 equals 7, so that was good. But I got -5 equaled, I think, 1.
Yes.
And that was false. So I threw out -5. Okay? Alright. Moving to the next one. I want to talk. Some of you got started on this one. If y'all could turn off again those side conversations, that would be wonderful. Thank you. I want to talk for a second, as you got to this one, about a few things that you're going to see. And then for the rest of class, you'll be back to just practice, and I'm not going to interrupt you again. We're going to do one multiple choice problem to close out to try to show you. I'm going to try to do more of like, this is how you would see this on the unit exam type stuff, so that we get like feel practice with that, okay? So I'll take like your last few minutes, but that's it. So here we go, we got one. First, our goal is to isolate the radical, which means raise your hand if you can tell me what we have to move out of the way to start off with here. Kaylin? Perfect. This 14 right now is bothering our radical. We want to move everything out of the way and get the radical like alone, isolated. So subtract it over. Cube root of x minus 5 squared equals, when you subtract it, I think you get 36. Okay. Here's where I've noticed some people going different ways with this one. So I want to talk about a couple of the strategies that you could try and kind of see which one you guys feel the most comfortable with. And in different classes today, I've like gone different directions. So I'm going to throw it back on y'all. What do y'all think? If I have a cube and a square, what are some possibilities for what I could try to do next? She, what are you thinking? Multiply times what? 3 times 2. Oh, gotcha. So something with, we said these like exponents right here. Let's rewrite this though. This wouldn't actually be 3. Remember, it would be 1/3. And so it'd be 1/3 times 2, which is 2/3. So you had x. You could rewrite it like this as x minus 5 to the 2/3 equals 36. And you could go like that sort of route. Do you know how you would get rid of this? Not sure? Okay, so like you can totally do that, and I could kind of like one off with you about then what we could do to both sides, but I'm going to leave that as like an option. Any other thoughts? What else could we try? I love it. Love the brave volunteers. Pick someone else, because I'm bad at calling on people. Okay, Rhiannon?
I'm not sure about it, but could you like cube both sides?
Do both sides on what?
Like cube both sides, and then you would just have like x minus 5.
Yeah, one option is definitely to try to get rid of that cube root first and cube both sides. So raise the power to your root, like we said, step 2, and we'll have x minus 5 squared equals. So the only thing about the strategy is you get like a really big number, right? 36 cubed is going to be huge.
46,656.
Cool. So if you have a calculator, like you'll be good to go because you can do 36 cubed. When I first did this, I went a different route because I was trying to do it by hand. I probably didn't have my calculator sitting right by me, and I was like, that seems really big. I wonder if there's a way I can work around this. So I want to point out one other quick thing, just to like keep plugging our properties of exponents. Remember, she pointed out that this is 2/3 if we have a 2 inside and a 3 outside.
Yeah.
Which means I could write this either how it was written, or the cube root of x minus 5 squared. I could put the square on the inside or the outside based off of the properties we talked about on Friday and like practiced in the do first yesterday. The reason I saw that and thought that was interesting is because I noticed this 36 is a perfect square, and so if I took the square root and canceled the square first, I was like with smaller numbers. But if you're like, that doesn't make sense in my brain, well, I'm going to go with y'all's route because this is what you guys like were telling me to do. But if you like making it equal to 6 and not picking up your calculator, like that could be a strategy, and then you would cube it after. Okay? So I'm just trying to show you like different methods that you could go with this. As long as it is like a legal algebra move, like this is a rule of exponents we know we can do, then you can go different routes on these types of problems, as long as you're not just like picking something random to do. But I'm going to come back to your example. So we're right here, because I saw some people doing this around the room. So now how do we undo our square, because we're trying to get x by itself? What are we going to do to both sides now? Kaylin?
Would you have to do the box method for that side?
Okay, another option. Raise your hand if you were thinking, like Kaylin, that maybe I can do my box method here and move this over. That is one way we could do this. Anyone had another thought? Leisha?
I have more like a question.
Uh-huh.
Okay, so you know how it's like a square root? Would it be able to like square? No.
It's a square, so what can we do? We can do a square root to both sides and like avoid our box to cancel that square. So that's another way that we could do it. So again, with this, there's like a lot of options. Okay, so let's go with this. If I take the square root of a square, I'll just have x minus 5 on this side. However, what you need to be careful about, which is why I'm like modeling this version, because what you need to be careful about when you square root both sides, you totally can. You can square root both sides. However, remember, when you use a square root as like an operation that you're doing to both sides of an equation, your answer is plus or minus whatever you get. So you always say, the answer here, I think you get 216, but it's actually plus or minus 216. So I'm going to break it off into two separate problems, and this is where our two different answers will come from. It could be either to 216 or negative 216. That's because this x minus 5 could have been positive or negative before we squared it, and both of those would have given us a positive 46,000. Like a positive or a negative underneath this square could have given us positive 46,000. So if you use that as your strategy, Laisha, that's a great strategy. You just have to be careful that you do the positive one and the negative one. Okay? Cool. So let's keep going. Now if I add 5 over, 216 plus 5 gives me 221. If I add 5 over here, negative 216 plus 5 gives you a negative, what did you get, Gio? 211. Okay? So here are two separate answers that we now need to, Michelle, what do we have to do last step every time when we get our answers? Michelle, plug them back in and make sure that when we plug both of them in, we get them equal to 50 because this side doesn't have an x. Okay? So go ahead. I take Pedra's question, but then I'm going to have you plug these in, and I'm going to let you just check these answers, and then move on to 4 and 5, just like on your own practicing for the rest of class. Question?
So I was going the route you were going.
This one?
The other one, but I erased it and went back to that one.
You like this one?
Yeah.
Okay.
I cubed 6.
Cube. But right here, same thing when I took the square root of both sides. This was plus or minus 6. So I have, really quick, two separate ones. Okay?
Oh, okay.
Cube it. X minus 5 equals 216. X minus 5 equals negative 216.
Yeah, but I did it to the bottom one.
So you gotta know that when I took the square root of both sides, anytime I'm rooting both sides as like something to both of them, I've gotta account for a positive or a negative of whatever number I get.
Because I just went there and they gave me a
So you only get one of them.
Yeah.
So you would have been missing one of them. So be careful about that. That's why we're going to bring us together for that one. So Rhiannon tested them. She found out both of them work. Anyone else?
No way.
Both of them end up working. Okay, so on to 4 and 5.
Yeah.
They do?
I'll go.
They do work.
Yeah, the 14's on the outside of the
Wait,
root.
that's not, wait.
Yes, thank you for waiting.
Are you sure?
Levy?
Yeah, they do.
Let's change.
Equals 50.
What kind of witchcraft is that?
You didn't plug in a negative 211, you plugged in a positive
The
211.
14 is outside.
What would be 48? Do you want me to check it? Let me see. You just plugged in a negative 221, but it was negative 211. So negative 221 doesn't work. Negative 16 plus 5 is not negative 221, it's negative 211. No. So we gotta check. They could both be good. They could only one be good. It's like you gotta check all of them. Okay, go on. Keep going. Keep going.
They both need the zero.
It shouldn't cancel. This should be. So this one's positive. So you can subtract it. And 18 is not gonna be. Do I owe you some? I remember. I feel like you volunteered him. Caitlin, do I still owe you a scan?
Stop. As I repaired it.
Alright, 4 good. You just practice that. The more you do, the better you feel. In all my other classes, everyone has finished all of these problems, so make sure you're getting through staff people. Your 18 shouldn't be level because you have minus 18 and you will be subtracting this 18. Minus 18 minus 18 is not going to cancel. So you'll have a middle term. What did you say this time? What did I say this time?
Let me, because x minus 5. This is only 1 minus 5. So then you put negative 2 and then plus 5, right? Negative 2 and then plus 5. How do you get? Whoa. I have a question. I did too. I said
Okay, I'm coming.
Okay, so if I did okay, so keep it in, right? Minus 5. X plus 5.
No. X minus 5
It's negative.
X minus 5.
equals negative 16.
Positive.
So that's what
So there's still X minus 5.
I thought when you said plus 5.
Okay, that means the root, like X minus 5 is X minus 5, but the square root of that 46,000 could have been a positive 216 or a negative 216. Cool?
That's what was confusing.
Very good, very good.
Oh,
How are we doing on this one? So you were doing right now.
I tried moving it to one side first before you try to play it.
Where do it? What are you going to do? Where it good? And here, that means you're gonna. Oh yeah.
You pitch me like that to you. You have no hair.
So start. You want to isolate. Okay. So I would start. You're gonna have to like usually just take one root. So let's start like right underneath. First thing is I would get the root by itself. Isolate the radical. So right now, if I look at this side, it's not just a radical. What else is there? Where's the number that we don't want?
Because you have to subtract
The 3. So I have to move this 3 to the other side to start off with, so that I have only the root. Like, so see here, we did 14 as our first step, so that we have only the roots over there. Okay, so move the 3 over. Then you can start this side. I would, okay, so this is good. Yeah. This is another one. Kind of like this one. Before you start, I would try to pull out backwards so you have a nicer one and you have poppers. So I would try to pull out a 9 and see what all the other alternatives by 9 and then they're easier. Still going? Okay, good. Okay, Okay, y'all, you've got 6 more minutes left. You should get to both of these. If you're still not done with the first one, pick up the pace, call me over if you're confused.
Oh, it's at.
Okay.
Is this like the
Yes, you can do that.
no? So this one.
Wait. I even forgot. Before you did this, this is good. You're going to do this in a second. So before you do this, I'm going to do
I didn't say that.
When you have 4x minus, or plus 3 minus 4. Yes, and now, minus 18. Minus, and minus, will not be 0. Or minus, how many minuses? When you subtracted 18 over, or sorry, added 18, you add 18, it should have been not 9. Check this number, and nothing to change. So, leave the other one.
No giving up.
No, it's both of them. Wait, no, figure both of them. Let me check mine. Yeah, it should be 3.
But you added to both sides to get
Good, now do your bottom.
I guess something next.
Negative 9. Oh, yes.
Negative 9 because they
These are
Yeah,
going to
X
add
plus
this and multiply this.
So it's like this little.
Be -1 and -3. -1 plus -3 is -4. -1 times -3 is positive. Focus. Try to get through all of them. Ooh, that's a lot of white. Okay. Try this one. First thing, we want to get this radical by itself. So we can't square it until we get this 3 out of the way. We want to isolate the radical first. So like see how here they moved the 2 first. So we want to move the 3 over, then you can square both sides. I'm going to check in a second. Keep going, last one. I think this one should have been 3 and 1 when I looked up there. Did you only get 3 to begin with? You're close here with your... Okay, when you added your 18, gotcha. You canceled the middle one, right? But if I subtract 18, this was a minus 18. And I had minus, and those didn't cancel, so you would have had your function. This one, they should have both worked. It should have been 1 and 3. Where's the thingy factor? Let's pull out, did you pull out a 9? Factor out a 9 in front and to make the numbers a little smaller. This is great.
So this answer is 3 and 4.
Yep. Yep. Multiply the add -4. So it has to add the -4. They're got to be negative. So it has to be 2 negatives to give you a positive when you multiply. Alright, eyes back up here. As promised, I'm going to go to our multiple choice problem last.
Oh.
It's just up here. I added it because like these notes we have just from districts that I add on to, so here we go. take a look so I can let you out on time. What do you want to prioritize here so I can let you out on time?
It's like when you pull a number out of the parentheses for finding an answer, what happens to that number?
Still there. Still there, but it won't affect your answers even if you drop it. It's still there. You can't just divide it away. Okay, so here we go. If you have something like this, and you're like, this is crazy complicated, you could square both sides and take all the time in the world doing all of these steps, and on like free response you will. However, who can think of a strategy on a multiple choice of how I could quickly see which of these solutions would work? Which of these solutions work? Diana? You can plug those numbers in. For example, the answer ends up being B. If you plug in 7 here, you'll get 3 on this side. Root 64 minus 5 is 8 minus 5, which is 3 on this side, and you'll say that's my answer. So you can just plug them in, quick, straight, one, multiple choice, alright?